The Earth is 4.54 billion years old, give or take 50 million years. That is an unimaginable number of birthdays. Over that vast span of time, our planet has been everything from a molten inferno to a frozen snowball, from a barren wasteland to a lush tropical paradise. In our previous journey, we traced more than 4 billion years of Earth's history from its fiery beginnings to a world teeming with primitive life. But the story was far from over. In fact, some of the most astonishing twists in this planetary saga took place not in the deep past, but in the relatively recent 300 million years. So let's imagine once again, what if alien scientists travelling across the galaxy stopped by Earth at different stages in its history? What kind of planet would they have encountered? Today, we will join them on another expedition. This time, our journey will carry us from the age of Pangaea through the most devastating extinction in Earth's history and into the time when dinosaurs ruled the land. Our alien explorers return about 180 million years ago in the early Permian period. The world before them looks strikingly different from the one we know today. The most dramatic change is the geography itself. Several continents, including Euramerica and Gondwana, have collided to form a single enormous landmass, the supercontinent known as Pangaea. Stretching across much of the globe, Pangaea is like a colossal beast sprawled across Earth's equator. At the heart of this supercontinent rises a brand new mountain range, the Central Pangaean Mountains, formed during the collision of these giant landmasses. Comparable in size to today's Himalayas, these mountains soar into the skies, reshaping not only the land but also the climate. Near the equator, Pangaea lies beneath the band of constant rainfall known as the equatorial rainy belt. On the southern side of the mountains, torrential rains feed dense forests and swampy lowlands. But to the north, the story is different. The towering peaks cast a vast rain shadow, turning much of Pangaea's interior into one of the largest deserts Earth has ever known. We still see this process at work today. The Gobi Desert exists in the rain shadow of the Himalayas. Now imagine that same effect magnified to a continental scale. That was the climate of Pangaea. And this isn't the only force shaping the planet's weather. The Earth is still in the fading stages of a long ice age known as the late Paleozoic icehouse. For tens of millions of years, glaciers had spread across the poles and high mountain ranges. This cooling may have been triggered by the spread of vast forests during the Carboniferous period, which increased oxygen levels and reduced carbon dioxide in the atmosphere, weakening the greenhouse effect. By the early Permian, however, the climate is shifting again. Ice caps are retreating, though glaciers remain in many mountain ranges. Earth is warming, but still cooler than today. Against this backdrop of fluctuating temperatures and shifting climates, life must find a way to adapt or perish. Where there is land, there is also ocean. The merging of continents has left behind a single vast super ocean, the Pangaea Ocean, sometimes called the Universal Sea. Covering nearly 70% of Earth's surface, it is a watery expanse larger than any ocean we know today. Alongside it lies a smaller body, the Paleotethys Sea, nestled between parts of the continental mass. If we dive beneath the waves with our alien visitors, we discover a thriving but sometimes terrifying ecosystem. Trilobites and nautiloids still drift through the waters, survivors from earlier ages. But they share their realm with stranger predators. One of the most extraordinary is Helicoprion, a shark-like fish, up to 8 meters long. Its lower jaw bears a spiral of teeth, arranged like a buzzsaw blade. It is an alien-looking adaptation likely used to shred and consume soft-bodied prey. To us, this predator would look as strange as anything conjured by science fiction. Yet, it was very real, a reminder that Earth's oceans have always been laboratories of bizarre innovation. Back on land, life is no less peculiar. Insects flourish, giant dragonflies with wingspans as large as seagulls, beetles of all kinds, and strange primitive orders now long extinct. Among amphibians, the boomerang-headed Diplocaulus prowls rivers and lakes, its unusual skull possibly helping it glide through water. But perhaps the most fascinating of all is Dimetrodon. Often mistaken for a dinosaur, it is in fact a synapsid, an ancient relative of mammals. Stretching 2 to 4 metres in length, Dimetrodon bears a distinctive sail along its back. This sail, with its network of blood vessels, may have helped it absorb heat from the sun, warming its body more quickly than its cold-blooded rivals. Here we see an early step in the evolutionary path toward warm-bloodedness, the same adaptation that keeps you and me alive today. But Earth's story is rarely stable. Around 252 million years ago, catastrophe strikes, the Permian-Triassic extinction event. This is the greatest mass extinction in our planet's history. Massive volcanic eruptions in what is now Siberia belch, enormous amounts of carbon dioxide into the atmosphere. Global temperatures soar, oceans become more acidic, suffocating marine life. Habitats collapse. The toll is staggering. Roughly 70% of vertebrate species on land vanish. In the oceans, about 80% of all species disappear forever. Life on Earth has faced extinctions before, but nothing on this scale. It is as though the script of life is nearly wiped clean, leaving behind a planet eerily quiet, emptied of its players. Yet even in devastation, opportunity awaits. From the survivors, new forms of life will emerge. The stage is cleared for the rise of creatures that will dominate the next chapter, the dinosaurs. Our alien explorers return about 150 million years ago in the late Jurassic period. The world before them is alive again, reshaped by millions of years of recovery and diversification. Pangaea has begun to break apart. In the north, Laurasia now contains what will become North America and Eurasia. In the south, Gondwana holds the future continents of South America, Africa, India, Australia, and Antarctica. Between them lies the Tethys Sea, an expanding waterway that will one day grow into the Atlantic Ocean. The climate is scorching. Temperatures are 5 to 10 degrees warmer than today, with carbon dioxide levels 4 times higher. With no large ice sheets at the poles, sea levels rise to heights far above modern levels, about 140 metres higher than today's. Forests even cover the polar regions with mild summers and snowy winters. Plants thrive in this warmth. Conifers and cycads spread across tropical and subtropical zones. Some, like the now extinct Araucaria mirabilis, look eerily similar to trees we still see today. But it is the animals that truly astonish. In the forests and plains, sauropods dominate. Among them is Supersaurus, stretching 35 metres long and weighing up to 40 metric tons. Imagine standing before a creature longer than a football field, grazing peacefully on treetops beyond your reach. Yet, not all dinosaurs are gentle giants. Lurking nearby is Allosaurus, a predator, nearly 10 metres long, armed with serrated teeth and powerful jaws. It stalks herds of sauropods, a reminder that in nature, even the greatest giants must always watch their backs. Above the forests, the skies come alive. Pterosaurs like Dimorphodon and Pterodactylus glide on leathery wings, hunting smaller animals. Sharing the skies is Archaeopteryx, one of the earliest birds, a feathered dinosaur that bridges the gap between reptiles and modern avians. And then in the undergrowth, a small shadow moves. It is no towering reptile, but a modest mammal-like creature called Tiniolobis, a member of the multituberculates, about the size of a rat covered in fur and warm-blooded. These creatures may seem insignificant beside the dinosaurs, but their brains are more developed, their behaviour more social, and their survival strategies more flexible. They are the quiet heirs to a distant future. Little do our alien scientists know that it is not the dinosaurs but the descendants of these small mammals that will one day inherit the Earth. Exhausted but awestruck, our alien explorers take to the skies once more. In just 130 million years of visits, they have witnessed Earth's landscapes transform, its climate swing between extremes, and its living creatures evolve in astonishing ways. From deserts to super oceans, from monstrous predators to tiny mammals, Earth's story is one of constant change and endless adaptation. And yet, the saga is not finished, for in the chapters ahead lie more cataclysms and more wonders, the fall of the dinosaurs, the rise of mammals, and eventually the appearance of a species capable of looking back at this story and asking how did we get here? That, of course, is us. So let's leave our alien travellers to their journey and prepare ourselves for the next stage in Earth's extraordinary history.